And welcome to the Evidence Reasons Academy. Welcome to this exciting show on geomagnetism. Oh boy. I'm sure you're all riveted with the potential drama. I'm just being sarcastic. This is a very important topic. Sometimes the most boring topics have the most influence on our lives. Just think about all the scientists that research electricity. There's a proverbial story where a woman asked Michael Faraday when he was researching electricity way back in the 19th century. The lady asked him, "What good is electricity?" And he responded, "My dear madam, what good is a baby?" And can you imagine the modern world without the electricity we have today? But we're going to be exploring electricity and magnetism. Faraday's law of induction deals with one relationship between electric currents and magnetism. Implicitly, we'll be doing a lot of Faraday's law, and this has a lot of implications for geomagnetism, and geomagnetism may have a lot of implications for the age of the Earth, which has a lot of implications for the age of the Earth, and therefore the genealogy of Christ and the authenticity of the Bible and the Christian faith. So this is why we should take it seriously, even though it's agonizing. It's torturous, it's gruesome. I have to occasionally remember Bugs Bunny saying "gruesome" in the cartoons. This is what it will be like. And Schnoil, God bless you, sir. He's been a faithful viewer of some of these nerd torture sessions, and this channel is definitely to explore the nitty gritty of this at the professional level. This is actually cutting edge creationism and actually dealing with possibly cutting edge secular science if the secular science would be willing to receive it. Geomagnetism is a big deal. The magnetic field could be decaying in 1600 years, and the end of the world, as far as human civilization at least, could be at our doorstep, relative to geological time. The geomagnetic field goes, then the solar winds can slowly erode away the Earth's atmosphere. The winds will hit the molecules of the Earth's atmosphere, put them at escape velocity, and outside of the gravitational field, and the atmosphere is gone. This does raise interesting questions about the age of the Earth. If it's known the magnetic field is decaying. It's about 6.3% per century. If we extrapolate that, either a linear or exponential decay, it's bad news. Some people will say, well, it's been stable for the last 7,000 years. It's like, well, how do you know that? We haven't had the precise measurements from 7,000 years ago like we're having them in the last 200 years, where we could actually have a good indication of magnetic field strength. Since it's been a while since I left off in the paper, I'm just going to go right to it. I'm going to read very quickly through the first section, and then we'll start slugging through the part where we left off last week, or 2 weeks ago, or however long ago. So if you see me looking back and forth, I actually have 5 cameras, 5 screens that I'm dealing with, and just so you know what's going on. So let me bring up, let's see if I have, do a share screen. Let me know if the audio is halfway working right, and we will proceed. Oh, for some reason, okay, I need to move things around a little bit. One moment. I shared the wrong screen. Try again. The link to this paper is in the video description and also Russell Humphrey's qualifications. He's eminently qualified to talk about this topic. So let's proceed. Let us work heartily unto the Lord. And Lord, enlighten us, help us to suffer through this tough material for your glory. In Jesus' name, amen. Planetary magnetic dynamo theories, the century of failure. D. Russell Humphreys, by D. Russell Humphreys, Creation Research Society. Abstract. For nearly a century, geoscientists who believe the Earth is billions of years old have been striving to develop a successful dynamo theory to explain how the Earth's magnetic field might maintain itself over that long time. After reviewing analytic theories, computer simulations, and laboratory experiments, I have concluded that all these efforts have fallen short of proving the geomagnetic field could be maintained by a dynamo. To contrast with this apparent failure, I touch upon the remarkable success of creationist theories in explaining magnetic fields in our solar system, especially the planet Mercury. This contrast supports the young biblical age of the world, about 6,000 years. And we have an audio check here. Thank you, Schnoil, for the feedback. See if I can even make this in full screen mode. Can the Earth's magnetic field maintain itself? The terrestrial globe is magnetic and is a lodestone, wrote Queen Elizabeth's personal physician over 4 centuries ago. I think a lodestone is just like a naturally magnetic stone. He was right about the magnetic field, but wrong about its cause. So he was right that the Earth is magnetic. Okay, he was right about the magnetic field, but wrong about its cause. What he called lodestone is magnetic, an iron oxide mineral that is permanently magnetized by the oriented spinning electric charges of electrons in its iron atoms. But below a few dozen kilometers, the Earth is too hot for any material, even pure iron, to remain magnetized. The thermal collisions of atoms are too vigorous to allow the spins to remain oriented. That leaves large-scale electric current in the interior as the only possible cause of the magnetic field. Electric current in the Earth's core is like a spinning flywheel. In Figure 2, Sir Joseph Larmor, 1857 to 1942. Left to itself, such a current would die away in less than a few dozen millennia, because electric resistance of any conceivable material in the interior would wear down the current, just as friction slows down a freely spinning flywheel. For creationists who are convinced by both the Bible and much scientific evidence that the Earth is only about 6,000 years old, such decay is no problem. In fact, it explains very nicely the steady weakening of the Earth's magnetic field for the past few centuries. Creationists theorize that God started the electric current when he created the Earth, doing likewise for the heavenly bodies. But uniformitarians who believe the Earth is billions of years old, I'm sorry that Humphreys put that in there. There's no need to use the word uniformitarians. He just has to say people who believe the Earth is billions of years old. I'm sorry I have to make a little commentary there. That's just a distraction. Assume that some natural process started the electric current and then maintained it for eons. Nearly a century ago, Sir Joseph Larmor, a well-known Irish-British physicist, was the first to suggest a scheme. It was an article trying to answer the question, how could a rotating body, such as the sun, become a magnet? He rejected several ingenious but implausible possibilities. Then he outlined a possible solution, the first in a long series of dynamo, the British word for electric generator, theories. And now I'm yawning. I feel so sorry for the audience. If I'm yawning, I know it's boring for you guys too. All right, let's go. Let's go, Brandon. In the case of the sun, internal motion of the conducting hot gas in a magnetic field induces an electric field acting on the moving matter. And if any conducting path around the solar axis happens to be open, an electric current will flow around it, which may in turn increase the inducing magnetic field. In this way, it is possible for the internal cyclic motion to act after the manner of a cycle of a self-exciting dynamo and maintain a permanent magnet from insignificant beginnings at the expense of some energy of the internal circulation. Whoa, that was a mouthful, and I don't know that we're going to uncoil this just by reading the paragraph over and over again. It might become clearer as we go on that this will become clear. Let me just All right, I'm going to have to go to my backup computer. I am having serious problems with my connection on my smartphone, and so you won't see my face. We'll continue. Show goes on. Self-exciting alludes to the type of generator that makes its own magnetic field without any need for an externally applied current or field. Later the same year, Larmor specifically included the Earth in his hypothesis. Ever since then, hundreds of geoscientists have worked hard on developing the hypothesis into a theory that works. They have done theoretical analysis, numerical simulations with large computers, and laboratory experiments. Here, I outlined the history of those efforts, showing that, astonishingly, they still have fallen short of proving that a dynamo is working or even could work in the case nearest us, the Earth's core. And thank you, Schnoil, for the feedback. Still okay. The importance of that apparent failure is that it leaves only one alternative explanation for the Earth's magnetic field: free decay of the electric current in the core. Free decay is only feasible over a period of thousands of years, not millions or billions of years. So the absence of a dynamo in the core supports the idea that the Earth is as young as a straightforward reading of the scripture says it is. This is kind of an interesting idea that maybe we could induce a current in, like, say, a circular piece of copper, and the current will kind of flow by momentum for a little bit, and then the friction will kind of erode the motion. So this is a very interesting experiment, and you can kind of indicate how long that electric field is present by watching the decay of the magnetic field. We can actually experiment with this. This would be a really cool experiment. So let me just say, what Humphreys is laying out here would be a really, really, really cool experiment if we could do it, if we can induce an electric field into a circular ring of copper and just let the electrons the electric current just kind of flow in a circle, and the resistance in the copper will slowly erode it away. That would be really totally cool. And as that, yeah, so according fairly, to the electromagnetic theory, as that current is circulating around, it's going to have a magnetic field associated with it. And as it starts to decrease, the magnetic field will decrease. Yeah, that would be totally cool. So this is not a dynamo theory. This is an alternative. So Humphreys is proposing only one alternative explanation for the Earth's magnetic field: free decay of the electric current in the core. So God put in electric current in the core, and that's slowly decaying. That is a really cool idea. Well done, Russell Humphreys. In the meantime, I'll check the status of my poor internet connection. It's coming back up. I don't know why it died. There might have been an electromagnetic disturbance. Speaking of electromagnetic theory. Okay, so there are the anti-dynamo theorems. After Larmor introduced the idea of a self-excited dynamo in the Earth, there was little comment in the scientific literature for over a decade. But in 1993, a young English astronomer with good training in mathematics, George Cowling, threw a big monkey wrench into the machinery of dynamos. With straightforward mathematics applied first to the magnetic fields of sunspots, Cowling showed that simple forms of the dynamo idea could not work. Considering magnetic fields, he wrote, Cowling, 1993, a field which resembles an axially symmetric field in certain respects cannot in general be maintained by the currents it itself sets up. We are led to conclude that the magnetic field of the sunspot is not self-maintained. For the same reason, general magnetic fields of the sun and earth cannot be self-maintained, as was suggested by Larmor. There's a picture of George Cowling. FRS means a Fellow of the Royal Society. That means he's top tier. And that's a photo from the Royal Astronomical Society. He passed away in 1990 in my lifetime. God bless him. God rest his soul. I hope he was a Christian. Self-excited electric generator. That's interesting. Driving steam engine. Background. That's interesting. Let me try to get my other source going here. Just one moment. See if I can come back online. Hang on. I'm still here, guys. Just having some technical problems. Nope, the internet's dead on my end. I'm going to do a power off and then a restart. Okay. Ben Rex, if you're listening, this is an interesting application of electromagnetic theory since you're an electrical engineer. I wouldn't know how to do this. That's described here, where we can, like, say, take a copper ring and get electric current to flow in it. So it's a ring. There has to be a way we can induce the current in it and then measure how the current slowly decays. I think that would be really, really interesting. I mean, that's basic electromagnetic theory, which I can't say I'm that good with. So anyway, just wanted to mention that. So unfortunately, this thing about axially symmetric, if I could have my camera working again, I could show it what it means. Unfortunately, since this poor thing is dead, I can't describe it visually. So I'm going to try to restart my smartphone so I can get my camera going. We'll just keep plowing away. I'm glad I'm reviewing from the top. This is really good. It's starting to make sense. So I'll summarize this because I figured it out the last time. It says, for planets, axially symmetric field means, okay, I'm not going to read the paragraph. Our magnetic field on the Earth is not axially symmetric. So the axis of rotation, if you rotate a globe or you rotate the Earth, at the North Pole, If you stood on the North Pole, you'd be spinning, and that'll help you define the axis of rotation. It's between the North and South Pole geographically. But the magnetic axis, where North Pole is about 10 degrees off. Is about 10 degrees off from the geographic North Pole. So unfortunately, this is a little bit, the wording of this is unnecessarily obtuse, but I'll read it anyway. For planets, axially symmetric field means that as you rotate azimuthally east or west around the magnetic axis, a line through the north and south magnetic poles, keeping your altitude and latitude constant, the field will remain constant. The magnetic field outside the Earth deviates from axial symmetry by less than 10% at any point. Cowling's results spurred a great deal of theoretical work to check it, generalize it, and look for loopholes. It was not only found valid, but over several decades, theorists found a series of anti-dynamo theorems that made Cowling's result more rigorous and more general. In 1956, they removed the restriction that the fluid velocity and the magnetic field direction must be in meridian planes. Okay, a meridian plane means you take one point, you take the North Pole and the South Pole, and you draw a plane that connects all 3 points. So just imagine taking a hatchet and cutting the North and South Pole in a way that you cut through an arbitrary point, a given point. Easier to show if I had a graphic. I wonder if I could actually show a picture of a meridian plane. Let me try to get you just that. One moment. See if I can get us all a meridian plane. It's worth 1,000 words. Okay, I think this is the best picture right here, one of the first ones. So a meridian plane, you could see it's just kind of like it's shaped like a dish, so to speak. It's like a frisbee or just kind of a flat circle. And it has to touch the North and South Pole, and then one additional point somewhere on the sphere. That's all. It's not a big deal. Okay. All right, so let's go back here. In 1956, they removed the restriction that the fluid velocity and the magnetic field direction must be in meridian planes. The following year, one of the theorists removed the restriction that the field must be steady. He showed that fluid motion cannot prevent the decay of the external dipole moment and cannot lengthen the decay of the dipole moment over a factor of about 4 over its decay time in the absence of fluid motion. A dipole moment. All right, so unfortunately that term has escaped me. There is an electromagnetic theory, what they call a dipole moment, and I believe it is tied to the magnetic field, so we can use the dipole moment kind of as a indicator of the field strength. That's all. So Humphreys explains it. External dipole moment is the strength of the electric current source in the core of the externally observed dipole, 2 magnetic poles, north and south, the main part for the Earth of the magnetic field. Okay, so we have like a north and south, which is the dipole. We have quadrupoles, which are 4 poles, et cetera, all the way up to some absurd number. I'm not good enough with electromagnetic theory to explain how that can all arise. But suffice to say, the north and south. The dipole is the one that your compass will pick up. It's the strongest. And we'll just go with that for now. Earth's dipole moment has been decaying steadily and rapidly over the last few centuries, as I'll touch upon in the next section. Two geoscientists who tried to simulate dynamo action in the Earth with supercomputers summarized generalized results of Cowling's theorem very simply. Robertson, Glotzmeyer, 2000, their italics. An asymmetric B, that is magnetic field, cannot be sustained by dynamo action. Bravo, Russell Humphreys. Bravo. Okay, now I'm going to try to get back online. And I may be able to succeed this time. Hang on. I'm going to try to, I'll have to cut some of my audio sources so I don't blow out your ears. All right, I think I'm back online. All right, thank you for bearing with me. The smartphone really overheats when I'm doing streams, and it's just messes up the electronics. I learned that in solid state physics, that heat really can mess up the functioning of transistors. Anyone who has seen the complex windings in an electric generator can see why a self-excited dynamo in the Earth is difficult for theorists to imagine. An engineer designing such a machine must first make an engine, in the figure perhaps a steam turbine, that converts undirected energy such as heat into directed energy in the form of a rotating shaft. The shaft drives a whirling set of armature windings in the generator section of the system. Okay, so I wonder why they call this a self-excited generator. Just say that it's a steam engine connected to a generator. And it says driving steam engine background. That's a misleading caption. It should say it's an electric generator with an engine driving the generator, and they could point to the, I think it's right here, the steam engine driving it is in the background. That would be much clearer. The first time I saw that was really painful. And greetings, Paleologos. Welcome to this nerd gruesome torture session. This is the place for professionals and guys serious about this. So this is a terrible caption here. This is the generator being powered by a steam engine in the background. That would have made it so much easier. So I'm sorry to nitpick, but in a paper this technical, every little bit helps if we can clarify things. What Russell Humphrey's point is, look how difficult it is to create an electric generator. Or look how difficult it is to make even the magnetic fields that are part of the generator. That's kind of interesting. You need electricity to make an electric field, and you need an electric field. You need electricity to make a magnetic field, and then the magnetic field is generated by electricity. So this is a little bit tricky how to get this all going when you don't have an initial magnetic field. In some of your like toy, not so sophisticated generators, you have a lodestone, a permanent magnet, and then you can use the permanent magnet, and you could use it. You could create the electricity without creating the magnetic field first, because it already exists. So if the magnetic field has to be created by the action of the steam turbine, that's kind of interesting that it could be self-excited. But he's just pointing out the complexity and the difficulty of designing this. So he's saying it's very hard for this to just spontaneously arise. And some of them have just said it can't be sustained. An asymmetric B field cannot be sustained by dynamo action. So asymmetric B, that is magnetic field, that is the kind of field we have on the Earth, because the magnetic north is not aligned with the geographic north. And they're saying this is unsustainable. And then Russell Humphreys cites this generator in figure 4, okay? And we'll continue. Anyone who has seen the complex windings in an electric generator can see why a self-excited dynamo in the Earth is difficult for theorists to imagine. An engineer designing such a machine must first make an engine, in the figure perhaps a steam turbine, that converts undirected energy, such as heat, into directed energy in the form of a rotating shaft. The shaft drives a whirling set of armature windings in the generator section of the system. This is really bad. You can't just throw heat at something and expect it to create a magnetic field. To be able to do that, where you take heat, like say from the sun, and generate a magnetic field, is like kind of tough. You need a machine. The engineer must then provide a way to extract electric current from the armature windings and connect it to the non-rotating outer world. Often he uses fixed brush electric contacts to sweep against the contact plates on the rotating shaft. Next, he siphons off some of the current output from the brushes and feeds it back with insulated wires into the fixed field winding placed around the armature. I mean, guys, this is just insane. You need insulation. That's like non-trivial, so that the electric current is nicely piped, piped around and flowing and not short-circuiting. This is not easy, guys. This is not easy. Next, he siphons off some of the current output from the brushes and feeds it back with insulated wires into the fixed field windings placed around the armature. That applies the magnetic field in the proper orientation to the armature windings. The windings moving forward through the field generate a current and send it to the brushes. The windings moving through the field generate the current and send it to the brushes. More current goes back to the field windings, making the field stronger. This quote-unquote self-exciting feedback process quickly builds up the magnetic field and current from essentially nothing, overcoming losses and providing a steady output from the generator. Okay, guys, I know this is confusing. This is why it's great if an electrical engineer is tackling this problem. You'll understand kind of the insanity of thinking a dynamo can self-assemble itself inside a planet and then being a self-exciting dynamo. It is just brutally crazy. Not quite as bad as abiogenesis, but it's getting up there. But the problems for dynamo theorists are much greater than for the generator designer. Just get that, guys. But the problem, okay, you think designing a generator is hard? The dynamo theorists have it even harder. But the problems for dynamo theorists are much greater than for the generator designer. The theorist must use only naturally occurring motions in the core fluid, powered only by natural processes. Without insulation or brushes, he must somehow find a way that electric currents in a conducting ball will travel in the special paths that will produce a magnetic field in the desired orientations and locations. Otherwise, the currents will travel in the simplest possible paths, as they would in a shorted circuit. See, I said short circuit. I could see that a bazillion miles away that's going to be a short circuit problem. That's why you have insulated wires, guys. He does not have the engineer's freedom to make things happen the way he wants. The dynamo theorist can only hope to uncover processes that already happen or perhaps don't really happen. Guys, for you electrical engineers out there and physicists who've studied electromagnetic theory, you should be lapping this up. This is great stuff. Now it kind of motivates me to love studying electromagnetic theory. I just want to study electromagnetic theory now and be agonized, have my brains just overheating, looking at Maxwell's equations, because this will tell us why the Earth has to have a God-created magnetic field that's decaying over time and will be gone in 1600 years or so, and that means the Lord Jesus is returning soon, because otherwise we're toast. Glory, hallelujah. So let's keep moving. And as exciting as that sound, boy, that did make me feel kind of sleepy. Goodness. So let's see. We're not even 20% through. Oh my goodness. Schnoil, I got to point this comment out. Perhaps the dynamo arrived by small steps, driven by natural selection. The anti-dynamo theorems have eliminated all the simple possibilities. The author of the most general theorem above concluded, Backus 1957, if the geomagnetic field is maintained by a self-excited dynamo, the absence of axis symmetry of the field is probably essential to generation and maintenance. Okay. In other words, he's saying maybe it's because it's asymmetric to the, the magnetic north is not aligned with the geographic north. I'm supposing that's a guess on his part, and that's why I laugh. The magnetic field outside the Earth is generally symmetric around its north-south magnetic axis. So Backus' comments means that if a dynamo is going to work, the field inside the Earth could not have such symmetry. Instead, it would have to deviate strongly from the symmetry from place to place. That means dynamo theorists have to abandon grand global explanations and examine specific local phenomenon. Their theories have to become much more complicated. Oh, Russell Humphreys, I'm so glad. God bless you, sir, for writing this. And you're making more sense. I'm really glad we're delving into this because, biology just dominates creationism, for understandable reasons. Magnetic theory is boring and it's tough. The complexity of biology, you could just look at one 5-minute video and say, God did it. I mean, it's just so powerful, but this stuff is tough. This is tough. Okay, so I'm about, let's see. Give me a moment. Let's see if we can get down to the references. I'm not even quite 20% through. So this is going to be a multi-part series, but let's just keep plugging through. And maybe we'll wrap it up. We've been going for 41 minutes. Oh yeah, this is plenty, guys. We'll just kind of call it a night after a little bit more, just so we could digest this. Earth's core, the scene of the action. Figure 5 shows a cross-section of the Earth. Decades of comparing data from seismic waves and whole Earth oscillations with high pressure and high temperature experiments have given geoscientists a good picture of what's in the interior. For the record, guys, do you see that very light crust in green? We haven't even drilled a fraction of that green layer. I mean, not even just, this is just, let's see, 3,000 kilometers. I don't know that we've even dug down more than, say, 15 kilometers. I mean, that is just a puny. So let's see, 30 kilometers would be 1%. This is 0.5%. We've only dug 0.5%, and that was with great difficulty. So we actually don't know we actually have not been able to go inside here and figure out what's actually there. This is all by seismic data and a lot of inference. It's not easy. I will, just for the sake of completeness, point out some people have theorized a hollow core in here. And it's like, well, yeah, that may sound kind of crazy, but no one really knows what's going on inside here, okay? Just need to point that out. So caveat emptor. Nearly 3,000 kilometers beneath our feet, below the solid rocky mantle, is a dense, hot fluid outer core. At the top, its density is 9.9 grams per cubic centimeter, almost twice as dense as the mantle rock just above it. Okay, so this is the outer core, and this is where it's very dense, and this is half as dense. Okay, at the bottom, over 2,200 kilometers lower, the fluid density is 12.2 grams per cubic centimeter. Below that is somewhat denser inner core that extends a little more than 1,200 kilometers down to the Earth's center. So it gets increasingly dense here, and then the denser solid inner core. Wow. I gotta just mention, there's a famous movie called To the Earth's Core starring James Mason, and there's a scene there where a rock is tumbling down, and it got copied in the Indiana Jones movie, Raiders of the Lost Ark. You know, when I was a kid, that was kind of one of my favorite shows. But it's really kind of on a ridiculous premise. There's no way anyone could get down there to the Earth's core. They would be burned up. It was based on, I guess, a Jules Verne science fiction when we were still naive about the structure of the Earth's core. I actually would like to see that because it's just pure fantasy and it was just a lot of fun. But supposedly these guys were able to burrow all the way into the Earth's core. It's just, that would be what, 3,000 kilometers plus 2,200? That's 5,200 kilometers plus 1,200, 6,400 kilometers. You know, we have, so I even understated it when I said 15 kilometers versus 3,000. It's more like 15 kilometers have we dug down relative to the 6,400 kilometers. That's deep, man. That's deep. Okay. We're at 45 minutes, and a standard college lecture is 50 minutes, so I know we're kind of running out of fuel here. All right, let me just take a look. All right. Pressure, temperature, and composition. The weight of the mantle makes the pressure. Oh, hang on. Let me get back to the picture here. Okay, so there's the cross section. The weight of the mantle makes the pressure at the top of the core about 13 million times atmospheric pressure, 1.3 million times atmospheric pressure. At such a high pressure, most materials have to be hotter than several thousand Kelvin to be molten. According to high pressure, high temperature experiments on likely materials, most of the atoms in the fluid's core have to be iron. No other element appears to fit the geophysical data. Current estimates, could have used the word present because current has electric connotations. Present estimates are zeroing in on a composition of about 80% iron atoms, with the remainder being some mixture of lighter elements, such as silicon and oxygen. First, principles calculation on such alloys give a temperature at the top of the outer core of about 4,000 to 4,200 Kelvin, making it literally white hot. It says here, large earthquakes can cause the whole earth to slowly shake like a bowl of jelly. The frequency, hours or days, of such whole earth oscillations give much information about the interior. Cool. All right. Maybe we'll call it a night. We're at 47 minutes. Class, and I include myself as part of the class because I'm learning. I'm just a reader here. Class, myself included. It's been a great session, and try to take these things in small bites so we can digest it. So, you know, and I find that very long lectures, you just don't retain anything like the last 2 hours. I've been in 3-hour lectures. The last 2 hours of that is tough. Okay, so perhaps the dynamo arrived by small steps driven by natural selection. Okay, guys, it's been a lot of fun. Thank you for joining me on this channel because I'm not having a lot of streams on my main channel. As you know, I'm involved in a lot of things right now, including a lawsuit. I'm involved in trying to renovate my house, and then I have to resume my scientific work as a molecular biophysics researcher and publishing. I'm trying to write books, and I may be going on speaking tours, etc., etc. So this should be, you know, I just won't have time to be doing as many streams as I was on Evidence and Reasons, at least for a while. So I want to thank everyone who's joined us, and we'll finish off maybe with some uh, closing credits. So Schnoil says, very interesting. I like that Dr. Humphreys also includes such general information. Oh yeah, this is great stuff. Dr. Humphreys worked for a high power electromagnetic applications for like General Electric, like, kind of the generators, I think, that were important for power transmission. And God bless you, Sal. I hope everything works out for you. And likewise, Schnoil. And now we'll be going to the closing credits. Just one moment and I'll set it up. Take care, everybody. May the grace of the Lord Jesus Christ be with your spirit.